Dear students, this is Someshwara, CSR. Now we are discussing JEE Main paper 2025 January 24th morning session paper. Let's go to the paper discussion. First one, for the given cell Fe plus 2 is aqueous, Ag plus aqueous gives rise to Fe plus 3 and Ag plus. The standard cell potential value of the reaction. Here first one is what the required is target is for the equation Fe plus 2 aqueous plus Ag plus aqueous gives rise to Fe plus 3 aqueous plus Ag as solid. This is a required equation. Okay na? Now first we want to calculate the E0 value of Fe plus 2 gives rise to Fe plus 3 aqueous. This is here plus electron. What is the E0 value? First target. So for this one, from equation, this is a 1. I am taking equation Fe plus 2 plus 2 electrons gives rise to Fe. This is I am taking is 1. What is the nth factor? Nth factor equal to 2. Therefore, delta Z0 1 is equal to minus NF E0 1. I am taking this is 1. What is the value of this one? Minus here 2 F and what is the value of this one? This is Y. This is Y. Okay. Now, next one. Fe plus 3 plus 3 electrons gives rise to Fe. What is the nth factor? Is a 3. Delta Z0 2 equal to minus NF E0 2. And now this, what is the value of this one? This is Z. Therefore, minus 3FZ. Okay. Now from these two equations, we want Fe plus 2 to Fe plus 3. Therefore, equation 1 minus 2. Okay na? This is Fe this value is delta. What is the required equation? Okay. Now then this is a delta Z0 1 equal to, or you take directly minus that is 1 minus 2. Therefore, is a minus, here minus, this is a plus. Okay. Therefore, Fe plus 2 gives rise to Fe plus 3. This is a cancel plus electron. What is the delta Z0 value is? We want this value. Here I am taking this is delta Z3 equal to delta Z0 1 minus delta Z0 2. Okay na? Now what is the value, what is the nth factor of this one? Nth factor equal to 1. Therefore minus 1 F E0 3 equal to this value. What is the value? This is 3F Z, and that is minus 2F Y. This is delta Z0 3. Okay na? I am taking this is equation 3. Okay, we are getting this one. Now we are going to the this one and this one. So what is that one? Next, Fe plus 2 gives rise to Fe plus 3 plus electron is delta Z0 equal to 3Fz minus 2Fy. So okay na? Now next equation Ag plus electron gives rise to Ag. What is the nth factor? Nth factor equal to 1. Therefore delta G0 4 equal to minus NF E0 equal to minus 1F. What is the value is X na? Therefore this is X. Okay. Now we want, what is the original equation? Required equation is, what is the required equation? This is our required equation. This is a required equation. Now then adding, this is Fe plus 2 plus Ag plus gives rise to Fe plus 3 plus no, okay. Now this is what the value of this one? This is Ag. Its nth factor equal to match this equation, nth factor is 1. Okay. Now how to get this equation? Delta Z0 required final is equal to delta Z0 3 plus delta Z0 4. Okay na? Now what is the nth factor of this one? Minus NF E0 final is equal to, what is the value? 1 minus 1F E0 is equal to, what is the total value of this one? You are adding this. What is the value? This is 3FZ, okay, minus 2FY minus then XF. Okay. Now minus and F is cancel, E0 final equal to, this is X plus minus na, is nothing but minus of XF plus 2FY minus 3FZ. Okay, minus minus cancel, what is the value? Minus F cancel, 2Y minus 3F. Okay na? This is the answer. Okay, clear? Next one. Answer is, this is second option. Next one. Following are 4 molecules P, Q, R and S. Which of the following 4 molecule react HBr fastly? That means HBr is an example for these are double bonded compound. So alkenes, then this is versus HBr in the presence of CCl4 or aqueous medium without peroxide. This is electrophilic addition reaction. Electrophilic addition reaction, what is the intermediate? Intermediate is carbocation. Carbocation. So more stable carbocation easily participate in the reaction. So required more stable carbocation. Carbocation. What is the order? Plus R greater than hyperconjugation greater than plus I. Clear? And here one more important point is carbocation. Here carbocation adjacent OR is there or OR, this is plus R effect. At the same time here carbocation adjacent carbon has OR group, that means OR is directly attached to the carbocation, that is a plus R. Okay, na? Then here this is minus I. This is the main concept. Clear? So OR or OH is directly attached to the carbocation, that is a plus R. At the same time carbocation adjacent carbon has alkyl group, OR group, that is minus I. Okay. Now here we go to first one. Here this is there. Now we are going to the two versions are there. This is possible. Then in this way here H plus, this is H plus. Now this is minus, here hydrogen, here plus. Then 2 degree carbocation. At the same time you go to this side, what happened? Here is the double bond. Now I am taking direction toward this side. Then here H plus is there. Then here minus, here hydrogen, here plus is there. This is near to the minus I, this is far to the minus I. That's why this is not preferable, this is preferable. Okay, even though is a secondary carbocation. Have you understood? Okay. Now okay, next second one is here, this is P, here we go to the Q. Here is a double bond. Now this is goes to this side, here H plus, this is here minus and hydrogen, here plus is there, here is a plus R effect, extremely stable. That's why this is option. Now we go to the, what is that? R. Okay, so CH3. This is going to this side. Here CH3, here plus. Here carbocation, 3 degree carbocation. Compared to this one, plus R is dominated. Next one is what is that? Yes. Either this side or this side equal priority, here plus. So this also 3 degree carbocation. In this 3 carbocation, how many alpha hydrogens are there? 3, 2, here 2. Alpha hydrogens are 3, here 2, here 2. Totally 7 are there. Here in this one, 3, here 2, here 1. So alpha hydrogens, how many are there? Here only 6. So what is the most stable? This is okay. I want to explain what is the order. So Q greater than, faster. Next one is R greater than, S greater than P. So option is Q. Clear? So in this one, inside concept is which is the most stable carbocation. Okay. Next one. 1 mole of the octahedral complex is given. What is the complex here? CO, NH3, taken 5, Cl3. This is. And then it gives 3 moles of ions, 3 moles. And then here is given one more concept. What is that? It reacts with AgNO3 to form 2 moles of AgCl. That means 2 Cl units are outside of the sphere. Okay. Now how to write this one? CO, NH3, here Cl, outside 2 Cls. Then that's why here how many are there? This is a number 5. So is dissociated, how many ions are there? In aqueous solution, CO, NH3, taken 5, Cl, here plus 2 Cl minus. So I equal to 3 is reacts with AgNO3. How many moles required? 2 moles required. Okay na? So option is this one. Okay. Simple question. Next one. Which of the following the carbocation from the most stable? Previous we discussed it, same concept. So here this is your carbocation. Here you go to there, we get a positive charge. What is that? And then here positive charge is there. Positive charge adjacent carbon, what is there? Minus I group is there. This is here. This is minus I. Clear? Is the stability low? Stability less. Okay. Now here you go into this one. Here you get a carbocation. Now this is plus R effect. This is plus R. Extremely stable. Stable. Now here you go into there, here. Then we get this one. Now is already carbonyl group. This is already deactivating group. Is pulling toward this side. Here positive charge is there. So this also unstable. Now you are going to this one. Here positive charge. Then this is plus R effect is there. Okay na? So after that this is the more stable. So we want most stable is this one. Clear? Okay. Carbocation, adjacent atom, heteroatomic lone pairs are there, that is a plus R. Adjacent carbon, that is a carbocation adjacent carbon, this one. Carbocation adjacent carbon has minus I group, that is a less stable, minus I effect. Okay. Next one. Which of the following is a linear combination of atomic orbital will lead to formation of molecular orbital? Okay. Here main important point is, here Z axis is internuclear axis, it is able to form sigma bond. Now first one is one, two, three, four, five. Then okay, and then here Z axis, I am taking, this is Z axis, this is Z, that is 2pz, 2pz. This is here x axis, I am taking, this is x axis, 2px, 2px. So this is not unable to form bond, that's why this is not possible, this is wrong. Clear? Now next one is s orbital and px. This is s orbital is okay. Next one is, this is a same, this one. Here we go to this one, this is not possible, this is not possible. Next one is dxy. xy is nothing but is in between the axis. This is. Next one is, this is a x square minus y square along the axis. Then this also not possible. Then zero overlapping. Clear? So this also wrong. Next one is here s and 2pz. Then this is s and here 2pz, 2pz. So here overlapping bond is possible. So this is correct. Okay, na? Next one is a 2pz. 2pz is this is a 2pz. This is x square minus, this is x square minus y square. This is 3d x square minus y square. Now this is z axis, this is x axis, is a perpendicular direction. There is no overlapping, is a perpendicular direction. So there is no overlapping, only D is the option. Okay, clear? This is z axis, this is a z axis, this is a perpendicular direction. Okay, Now, which of the following ions are strongest? Then, which of the following ion is the strongest oxidizing agent? Okay, it's a simple question. There is no concept. Just lanthanide ions. Here +3 is a general and stable oxidation state. Stable oxidation state. Clear? Now, next one is Ln lanthanides +4 oxidation state. +4. Then one more is lanthanides +2 oxidation state. +2. So, we are going to this side, this one. What the process is the oxidation. So, this is reducing agent. Clear? At the same time, here you go to this side. This is reduction. That's why it acts as a oxidizing agent. So, here this one. This is the, we are asking strongest oxidizing agent. Tb +4 changes to +3 configuration, general. Any transition element is general oxidation state equal to +3. Okay. Then, clear? Next one. Ksp of CrOH taken thrice is 1.6 into 10 power minus 30. Then, solubility is normal question. CrOH taken thrice gives rise to Cr +3 plus 3 OH minus. This is saturated solution. This is a solid. Now, this is a S solubility. This is 3S. Therefore, Ksp equal to Cr +3 concentration into OH minus N concentration whole cube. Therefore, here this is a S, this is 3S whole cube. This is what is the value? S into 27 S cube. Therefore, 27 S power 4. What is the value of this one? 1.6 into 10 power minus 30. Therefore, S power 4 equal to 1.6 into 10 power minus 30 by 27. Therefore, S equal to 1.6 into 10 power 30 by 27 whole power 1/4, or this is 4th root of, okay na? So, option is this one, okay, simple question. Here we need not to do this one. I give the simple code. AB is given, AB type. Here is a 1, here 1. This is Ksp equal to S square, is a square. Now, AB2 or A2B is there. Here 1 plus 2. Here we are adding 1 plus 2. Total equal to 3. We are getting, I don't go to the coefficient value. Ksp equal to generally 4s cube. Here I am talking about 3. Next one is AB3 or A3B. What is the value? 1, 3. Totally 4. So, Ksp is directly proportional to S power 4. That means this is here what is that? 27 S power 4. At the same time, AB4 or Okay na? Then A2B3 is there then, or A3B2. Here what is the value? 5. Therefore KSP equal to 108 power S power 5. At the same time AX, my point is KSP is directly proportional to S square. Here KSP is directly proportional to S power 3. Here AXBY is there. Therefore KSP equal to X power X, Y power Y, S power X plus Y. Therefore KSP is directly proportional to S power X plus Y. Now here we go to this one. What is the value? 1 and 3, totally 4. Here 4 only, this is there. Need not to do any solvation. Clear? Now let's consider the endothermic reaction. Then first we are discussing about the conclusion of the thermodynamics. Conclusion. What is the conclusion of thermodynamics? Delta H, delta S and delta G. So spontaneous at all temperatures, this is minus, here plus minus. Then non-spontaneous at all temperatures. Then this is the reverse, here plus minus, here plus. Next one is here spontaneous at low temperature. Then is a spontaneous, is a minus, all are negative signs. Non-spontaneous at low temperature, non-spontaneous. Deciding factor is this one, deciding factor. So this is a plus, plus and plus is a low temperature. At the same time spontaneous at high temperature, then is a minus, here plus and plus. Non-spontaneous at high temperature, then this is plus, minus, here minus. This is a conclusion of the thermodynamics. Okay. Then this is a concept, important concept. Now you are going to that. What is the given condition? First endothermic is given. First case, two cases are there in this one. First case endothermic. This is endothermic. And then here freezing point, low temperature. What is the condition? Delta case 1. We need not case 1, we need case 2. Second part is there, we want case 2. Okay. So here case 1, endothermic, delta H equal to positive. Here non-spontaneous, delta G equal to positive. Low temperature, delta S also positive. This is a first case. Now what is that? However, the reaction is spontaneous at boiling point. So spontaneous, case 2. Our required. Here spontaneous, delta G equal to negative. Clear? Next one, at a high temperature, this is boiling point, that is the high temperature. Delta H equal to positive, delta S equal to positive. What case is this one? This one. So option is both are positives. Clear? Have you understood? Okay. Now, given below are two statements. Then statement 1, Dumas method is used to estimation of, okay, here estimation is different, identification is different, okay na? Identification of nitrogen or detection of nitrogen by Larsen test. But here detection, two methods are there, Dumas and Aldol method. Here Dumas method, here Dumas. This is a correct statement. Dumas method involved in formation of ammonium sulfate is wrong. So in Dumas method, Dumas, given compound is heated with cupric oxide, nitrogen gas is evolved, estimated through that one. That's why percentage of nitrogen equal to 28 by 22,400 into volume of N2 gas at STP by weight of organic compound into 100. This is, but Aldol method is there. Aldols, that is here concentrated H2SO4, catalyst CuSO4 or mercury, elevator is K2SO4. In this one, first step is ammonium sulfate is strongly heated with the second part, that is changes to ammonia gas, is not a correct. This is related to the Aldol method. Okay, option is first one is correct, second one is incorrect. Okay, this one clear. Now, which of the following statements are not true about the periodic table? Periodic table. So you don't mention here periodic table means modern periodic table, Mendeleev periodic table. Okay na? So here what is the options? AB combination is not there in the options. That is one more advantage, because then Mendeleev, the properties of element periodic functions are their atomic weight. Then next one is properties of elements are functions of atomic number. This is mostly. Generally periodic table is nothing but present periodic table. You won't mention anything is. That is a somewhat confusion is there. So to avoid that confusion, he gave solution. What is that? Both are not given. Done. So properties of elements periodic function. This is a correct. And that means this is modern periodic table. Sir, why you take modern periodic table? Here AB combination is not there. AB combination is there, that at that time you get a confusion. So this is okay na? We want not true. Okay na? So this is correct. Okay. Now here we go to the elements having similar outermost electronic configuration of the same period is wrong. Is related to the group. Next one. So next one is elements and elements located reflects the quantum numbers of the last filled orbital. Obviously that is a S orbital, some S block, P block, D block. This is a correct statement. Next one. So the number of elements in a period is same as the number of atomic orbital available in energy level that is being the filled. Is wrong. Is wrong. So number of elements present in the period is not decided by atomic orbitals. So in this one, what are the possibilities? Here C is C. Next one is C and E. One more D is correct. Okay, that's why including this one, this is the option. That is the option. This is the option. Then here considered, okay na, modern periodic table. So option is properties of elements are functions of atomic weight. That is not a correct for the modern periodic table. So option is this one. Okay. Now, carbohydrate ribose present in the DNA. What is the story of DNA? Oh, sorry, ribose. Here, ribose. Ribose. C5H2O taken 5. That means C5H10O5. This is a pentose. Here, this is a pentose. Pentose. Okay. Next one. Here, two type of structures are there. Pyranose structures and furanose structures. Here, pyranose structures are nothing but pyranose. That is 6-member rings. Furanose is what points are there? I am explaining. Next I explain the what is the required. Okay. Then furanose structures. This is 5-member rings. Next, here what is the original structure? CHO. This is OH. CH2OH. In glucose, second carbon is removed, you get this structure. Okay. Then this is okay na. I am talking about the ribose. I am not talking about the RNA and DNA. First I explain the what is the ribose, what is the character. After that, what is the DNA ribose, deoxyribose. This is oxyribose. This is both are in here. This one in same side. This is alpha. Then oxyribose. Oxygen is there here. Then this is beta oxyribose. This is oxyribose. Now, then we go to the DNA. Deoxyribose. What is the deoxyribose? We take this one is a beta form. This is alpha form. This is a beta. Is a stable. Is a stable. This is unstable. Okay na? Then and then here we go to this one. What kind of direction is there? This is right side. This is a D form. Clear? Next one. This is anomeric carbon. Anomeric carbon is nothing but either 5-membered or 6-membered. This is OH group is there. Here is a up or down, not a criteria. I am talking about this is OH. All four are reduced sugars. Reduced. Why? This is anomeric carbon. Anomeric carbon has OH group is there. They are reduced sugars. Clear? Any kind in carbohydrates. What is a reduced sugar? What is a non-reduced sugar? Why sucrose is not a reduced sugar? There is no anomeric OH group. Clear? Now, we want this is deoxyribose. This is in RNA. This is in DNA, deoxyribose. Here oxygen is not there, that is okay na. What is the alpha? Alpha is nothing but alpha is this is now in DNA this is available. Now we are coming to the point. Clear? One is a pentose. Is a pentose na? Is it clear? Is it correct? Is a pentose. Is a D configuration. Is a D configuration. This is A is correct. Then this is present in the pyranose. Or the pyranose? Pyranose is 6 membered. Here 5 membered ring is there. This is wrong. Clear? This is a correct. Is a reduced sugar? Yes, is a reduced sugar. Why? Anomeric carbon is there. Not only that, all forms, alpha, beta, all are reduced sugars. This is a correct. Is a alpha form? Is alpha is wrong. Is a beta form is present in this one. So what are the correct options? Correct options are A, C, D. So option is this one. Clear? Okay. Now, a preparation of potassium permanganate from MnO2 involved in 2 steps of process. Okay, everyone knows is a regular concept. The first step in a reaction, KOH and K1O2 produces. First step is this one. Then MnO2 is fused with alkali metal hydroxide and oxidizing agent like KNO3 to get K2MnO4 is a step 1. In step 2, electrolytic oxidation in alkaline solution to get KMnO4. Clear? Now here MnO2 plus KOH and O2 is strongly heated, then K2MnO4 plus H2O. Here 2 is a 4. Okay na? Is a direct from NCERT. Okay. Now, the large difference in melting and boiling point of oxygen and sulfur due to then atomicity. Oxygen atomicity equal to 2. Atomicity equal to 2 and linear. Sulfur is S8. Atomicity equal to 8. It is a crown shape. Then here sulfur, then so each sulfur covalence equal to 2. Each sulfur has a 2 lone pairs. In this nomen sigma bonds 1, 2, 3, 4, 5, 6, 7, 8. Clear? Atomicity equal to 2. Okay. How many lone pairs are there? Each sulfur atom has 2. Option is this one. Now, N2 O5 gives rise to 2NO2 plus half O2 present in the volume of the container. No products were present initially. The total pressure of the system when 50% of the reaction get completed. Okay. General question. N2O5 gives rise to then 2NO2 plus half O2. All are gases. Okay. Now I am taking initial pressure 1, that is a P0, or I am taking P0 equal to 1 atm. Clear? Then 0, 0, initial pressure, initial pressure in atm. Clear? Now equilibrium, equilibrium pressure 1 minus alpha, here 2 alpha, this is alpha by 2. Okay, na? Now this is what do you ask, is alpha equal to what is the total? Total pressure or equilibrium pressure is equal to 1 minus alpha, 2 alpha plus alpha by 2, alpha by 2. Clear? Now this is 1 plus alpha by 2, that is alpha 3 alpha by 2. Okay, na? Here alpha equal to how much? 50% is given, that is 0.5 equal to 1 by 2. Therefore 1 plus 3 into 1 by 2 by 2 equal to 1 plus 3 by 4. 4 plus 3 by 4 equal to 7 by 4. Okay, na? 7 by 4. Therefore, what is the equilibrium pressure equal to 7 by 4 or into 1, that is 75 into initial. Clear? This is option. Okay? Okay, na? Now, which of the following arrangements with respect to reactivity in nucleophilic addition reactions? Nucleophilic addition, aldehydes and ketones are involved in nucleophilic addition reaction. Is it clear? So, is the guest is what is the guest? Reaction starts with aldehydes and ketones are involved in nucleophilic addition reactions because aldehydes and ketones are electrophiles. So, what is the guest? Nucleophile. Okay, nucleophile is coming. Here, carbonyl group deadly deficiency is there, is effectively attacked. Clear? That's why aldehydes and ketones, aldehydes and ketones with electron withdrawing groups are favorable for aldehydes and ketones with electron withdrawing groups are favorable for nucleophilic addition reaction. Therefore, we are talking about generally aldehydes, benzaldehyde, ketones, aromatic ketones. That is the stability order, especially in this one. Here, benzaldehyde with electron withdrawing groups greater than is the benzaldehyde with electron releasing groups is greater than aromatic ketones. Okay, this is the order. Okay, now here benzaldehyde estophenone, what is the content? Estophenone. We are required, what is the order? Then estophenone, then nitro group. Okay, that is the option is benzaldehyde is there. What are the compound in all four? One is benzaldehyde. One is benzaldehyde. Next one is estophenone. Estophenone. What is the next compound? Para-tollaldehyde. This is CH3. Next one is a nitro group. Okay. These are the given compounds. What is the first one? Most active compound is this one. Next one is this one. Next is this one. Least is this one. Okay. What is the order? What is the compound? Estophenone, para-tollaldehyde, next benzaldehyde. This is the option. Clear? Okay. Next one. Good one. Standard question. So here is one compound is given. That compound has been asked, synthesis of a molecule is given, is prepared by the Aldol condensation. We want retro-Aldol. Retro-Aldol means Aldol product to what are the reactants? Reactant to what is that? This is the ozenolysis product. So I am going to the reverse process. A reverse process is nothing but we want retro. That is retro Aldol condensation. Next one, retro-ozenolysis. Retro-ozenolysis. Retro means we go to the, based on the product, we can identify the reactant. That process is called retro. Okay, na? Now, I am taking reactant. Then C double bond O CH3. Clear? Then how to identify the its reactant? To remove double bond, in which side oxygens are there, that side I am adding water. In water is water. Here 2 hydrogen, 1 oxygen is there. In which side oxygen part is there, that side don't add the oxygen. So here oxygen is there, that's why you are adding this side 2 hydrogens. Here this side 2 hydrogen. In which side of the double bond there is no oxygen, that side you are adding oxygen. Very important. In which side we want to remove the double bond, from that one we want to get the reactant. So this is, I go to the reverse process. This one here CHO, CH2, CH2, CH2. This is CHO. then okay na, next double bond O CH3. Now I am saying that this is this one CHO, okay na, here CHO, here CH2. How many CH2 groups are there? 1, 2, 3, 4. So CH2, 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 C double bond O, then this is CH3. Clear? This is subjected to Aldol condensation. This goes to, now here treated with dilute base and heated, we get that one. Clear? Now we want, that is, this is a formed due to ozonolysis. How to get the ozonolysis product? Where oxygens are there, to remove that oxygen, we are adding double bond. So these two oxygens are removed. These two oxygens are removed. In that place, you get a double bond. You get a reactant. Then, so how many member ring? 1, 2, 3, 4, 5, 6 member ring. Here is a double bond. In this one, methyl group is there. That means CH2, 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 here CH, double bond, here C, here CH3. Okay na? This is subjected to ozonolysis. Zn H2O, we get here O and O. Get that. Clear? So option is this one. Important model. Either JEE Main and Advanced is one of the important models. Okay na? Now this is from direct NCERT. Have taken two samples. This is pure solvent, and then you are adding a spoon of non-volatile or 2 spoons of non-volatile solute. That's why this is a solution. According to that, here vapor pressure. Here this is a P0 and this is a PS. Clear? What is the higher value? Due to non-volatile solute, vapor pressure of solution decreases, P0 greater than PS. Clear? Next one, freezing point. Freezing point. Here T0, this is a TF. Depression in freezing point. Due to adding of non-volatile solute to the solvent, its freezing point decreases. That's why T0 greater than is a TF. Okay na? Now this is vapor pressure, this is freezing point, and then here is a frozen area, Now we are going to this one is a pure solvent, is a solution. Now, this is frozen area, this is P0, this is PS, this is T, this is here T0, this is TF. Clear? Okay, na? This point, pure solvent. Based on this data, what is the option? This one. Need not to draw any diagrams, just vapor pressure of pure solvent is higher and vapor pressure of solution containing non-volatile solute is decreases. At the same time, this is here, this is a T0 pure solvent, this is a solution is low. Here vapor pressures. Clear? Okay. Now, which of the following statement is true with respect to H2O, ammonia and methane? The central atom in all molecules in sp3 is the correct. Then H2O is involved in all in H2O, then NH3, then CH4. Now, this involved in this one, and this is involved in sp3 hybridizations. sp3. Okay. Now, this is a correct statement. Then bond angles, due to lone pairs bond angle decreases, is this is a correct 104.5, 107.5, then this also correct. Next one is a dipole moment. So, its moment value equal to this is then its mu value not equal to 0, its mu equal to 1.85 divided by mu not equal to 0, mu equal to 1.47 divided by here mu equal to 0. So, this is a dipole moment. This is increasing order of dipole moment 0. This also correct. Okay, na? Both H2O and ammonia are Lewis acids, and CH4 is a Lewis base. No, is no. This never act as a Lewis acid or Lewis base. Okay, na? This is a wrong statement. Now, and one more important point is, these two are ammonia and water is Lewis bases, not Lewis acids. Then next one is here E. NH3 plus H2O, NH4 plus OH minus, and therefore this one. Then ammonia changes to ammonium ion by gain of proton. here this is loss of proton. That's why this is Brownstein-Lowry proton acceptor. Brownstein-Lowry, this is base. This is Brownstein-Lowry acid. And what is it given here? A solution ammonia in water is a base. In this, here is a base. In this, okay na? Ammonia and H2 act as Brownstein acid and base. So this is a base na? Is a base, Bl base. This is Bl acid. What is it given? Ammonia is a acid, is a wrong. So what is the correct option? Only so option is 1. Clear? A, B, C. Okay. Now statement 1, the conversion of proceed well in the less polar medium. This is more polar medium. Here we observed or not, both are, what is that, primary alkyl halide, both are SN2 reactions. So here CH3, CH2, 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 Cl, then you are using nucleophile, is the SN2 reaction, then this is carbon, hydrogen, here hydrogen, this is here going to this side, a nucleophile attack from the back side. This is Cl minus, partially negative charge, here C4 H9, okay na, sorry, this is C4 H9, or you take one alkyl group, is not a problem. C4 H9, this is nucleophile, is a partially negative charge, is a transition state. This is a process. Clear? Or we take is not a here, this is a hydrogen, this one. Now here you go to first one. In this one, here 2 are there. This is OH minus ion is there, then OH minus ion is already strong nucleophile, charged particle, charged. This is more polar, more reactants totally is more polar, So then in this case is already polarity is there. In SN2 reaction, what is the intermediate transition state? In SN1 reaction, what is the intermediate? Carbocation. Carbocation is a purely ionized ion. So we need not purely ionized ion. Then polarity is less. That means this is here. Lesser charges are there. Lesser charge. What is the meaning of that? Here C hydrogen, then C4H9, here hydrogen, here Cl minus, Then this is OH minus. OH minus. So is already more polar there. That's why here solvent compulsory. Solvent should have, in this case, solvent should have less polar. Due to that, what happened? Stability of its activation energy decreases. At the same time, here polar solvent is used, already polar, that is a highly polarity is there. That is why here less polar solvent is favorable. At that time, stability of transition state increases, is favorable for the formation of product. Okay, na? At the same time, here this is a transition state. Then after that you get a product, gives the SN2 product. Then we are using here that is, what is this one? NR3 is a nucleophile, is a less polar. Here polarity charge is very less polar. So at that time, solvent with more polar is favorable. Solvent should have more polar is stabilize the transition state of listen, in this one, this is NR3 here plus. So here is a bulkiness is there. In this one, more polarity group is there, is easily is removed from this one. Then simply, what is the logic in this one? Both are SN2 reactions. Transition state is formed in the both the reactions. Transition state is stabilize the reagent. Then that means what is that? Transition state of the intermediate is more stable, is favorable for the formation of large amount of product. That is decided by the solvent. Is more polar, less polar solvent is favorable. At that time, its stabilization increases. Now here you go to, this is less polar. At that same time, we are using more polar solvent, reduce the activation energy. That means its stability increases. That means easily form the product. So SN2, okay na? Here important point is, here solvent more polar, less polar means what is the meaning? Is a dipole moment is a little bit. In both cases, don't confuse about that. Sir, is not a SN1 reaction, is SN2 reaction, solvent. In both cases, what is the solvent? Polar aprotic solvent. Polar aprotic solvent with more dipole moment. For next one is polar aprotic solvent with less dipole moment. That is the meaning. Clear? So option is both are correct statements. This is here. This is less polar medium means what is the meaning of that? Polar aprotic solvent with less dipole moment. This is more polar medium means polariprotic solvent with more dipole moment. That is the meaning. Clear? It's okay. Next one. The product A formed in the following sequence. What is the first one? CH3 C triple bond CH. Clear? Then first one is, here 3 steps are there. Then a hydrolysis, H2O in the presence of Hg plus 2 and H plus. Okay, this is in hydration. Then is follows Markovnikov rule. This is CH3, then is a double bond CH2, this is OH, enol form. Is involved in tautomerism. Then CH3 C double bond O CH3 acetone. This is a 1. Next is treated with HCN. Then HCN cyanohydrin. Okay, what is the product? CH3 COH, here CN and CH3. This is a second product. Now is treated with H2 in the presence of nickel. Reduction. Cyanide changes to primary amines. That is CH3 COH CH3 C triple bond N. Okay na? This one. Now CH3 COH, then CH2 NH2 and this is CH3. Clear? Okay. What is the option? Option is CH3 OH. This is the option. Okay na? NH2 tertiary. This is the option. Okay. This is also simple. Next one. Here 71. 37.8 grams of N2O5 was taken in 1 liter vessel and allowed to undergo reaction at 500 K. Okay. In this one, what is the total pressure at equilibrium state? Is a Kp. First, we want to calculate moles. So, for easy convenience, I am explaining through the. Then here. Okay, na? This is the question. Now, first we calculate the, what is the target? Is the target is Kp. 2 N2O5 reversible reaction to N2O4 plus O2. Then Kp equal to pressure of N2O4 whole square, pressure of O2 by pressure of N2O5 whole square. This is a target. Next one is a given. First we calculate the moles. Moles. How many moles? Mole equal to weight by molecular mass. Then 37.8 by its molecular mass equal to 108. N2O5, its molecular mass is, this is 108. How many moles are there? 0.35 moles. Okay. This is given moles. Next, we want a pressure. PV equal to nRT. Then P equal to initial pressure is equal to how much? What is the initial pressure? 0.35 into 0.082 is given and 500 by 1. Okay na? What is the value? This is 14.35. This is a P0 value. Initial pressure. Initial pressure. This is a initial pressure value. Okay. Now, we want to find out what is the given total pressure at equilibrium is given. Total pressure at equilibrium. N2O5 gives us initial pressure equal to P0, 0, 0. Then P0 minus alpha, 2 units value equal to alpha, 1 unit value equal to alpha by 2. That's why P0 minus alpha is the alpha, this is alpha by 2. Clear? Now, here what is the total pressure? Total pressure equal to sum of these 3. P0 minus alpha plus alpha by 2. Okay, na? Now, in this one total pressure equal to how much is given? Already given total pressure equal to 18.65 is given. 18.65 equal to P0. What is the P0 calculated value? 14.35 plus alpha by 2. We are calculating alpha by 2 value. Alpha by 2 equal to how much? 4.3 bar. Okay, na? Now, here we want what the values required? P0 minus alpha. This is alpha, alpha by 2. We get only alpha. Alpha by 2 equal to, sorry, this is alpha by 2. Alpha value equal to its double. Then 8.6. Now, P0 minus alpha equal to 14.85 minus, what is that alpha? 8.6. Total value equal to how much? 5.75 bar for P0 minus alpha. We substitute there. Then here we required this is alpha square by alpha by 2, alpha square into alpha by 2 divided by P0 minus alpha whole square. Okay, na? You are getting 9.62 bar. We want in 10 power minus 2. Therefore, what is the value of this one? 962 into 10 power minus 2 bar. Okay. Okay, na? Question number 72 is a simple question. Here, standard entropies of X2, Y2 and XY5. That is 70, 50 and 110 joule per Kelvin per mole respectively. Temperature in Kelvin at which? At equilibrium state, delta H value is given. According to this one, delta G equal to delta G0, then delta G equal to delta G0 minus T into delta S. Clear? Now, at equilibrium state, this value equal to 0, then delta H minus T into delta S equal to 0. Therefore, delta H equal to T into delta S. Therefore, T equal to equilibrium temperature equal to delta H by delta S. Now, here delta H value is given. Delta H value. What is the value? This is minus. This is in kilojoule. These are in joules. These are in joules. This is in kilojoule. Therefore, then we want to find out the delta S. Already we got the, already in the given question delta H already given. Delta S equal to entropy of products minus entropy of reactants. What is the reaction? Reaction is half x2 plus 5 by 2 y2 gives rise to x y5. Therefore, this is the values. We get a delta H value equal to minus 50 joule per mole. Then we are substituting the value 0.7 into 10 cube. Then this is 700 K. Clear? Next one. Simplest question. Here x grams of benzoic acid on reacts with aqueous sodium bicarbonate releases CO2 gas that occupies 11.2 liter volume at STP. What is the x? First, this kind of basic question, very simple. First one is equation. First step is equation. Second step is marking. Third step is what is the standard moles. Then fourth one is what is given moles. Fifth one is answered. Any basic concept questions. First, making of equation. Second one is a marking. Marking is a very important point. What is the marking? I explain. Next one is third. What is that? Given moles. Sorry, what is the standard moles as per the equation? Next one is what is the given moles. Fifth step is answered. So first equation is a benzoic acid is treated with sodium bicarbonate. You get a CO2 gas. We need not, for this question, need not any kind of equation. We want benzoic acid and CO2. That's enough. For formality, I am writing equation. But CO2. Here marking. In this one, what is the relation? Benzoic acid versus CO2. Here how many moles are there in the equation? 1 mole. That is a marking. That is so what I said, that equation marking, that is a marking. Next one. What is the standard moles? Here 1 mole, here 1 mole. 1 mole of benzoic acid and 1 mole of CO2. Here is 1 mole is how to take volume, weight or liters or molecule, that is depends upon the given data. Here this is in grams, that's why I am taking the gram. This is in volume is there, that's why I am taking 1 mole is a 22.4 liters. Okay na? So this also weight is given, we take 44. Based on the given data, we take 1 mole equal to molecular mass or 22.4 liters or Avogadro number of molecules. Okay na? This is. We want for 11.2, how much? This is divided by 61. Clear? This is. Okay. Next one. Among the following cations, the number of cations which will give the characteristic precipitate in their identification of test with potassium ferrocyanide. Very important. Then, according to NCERT, potassium ferrocyanide is used for 3 identification of cations. Copper plus 2 reacts with this one, you take a copper, this is the second group. Given salt is treated with HCl, no test, after passing the H2S gas, you get a black precipitate. After that, potassium ferrocyanide is added, you get a chocolate brown, that is a copper. Clear? Next one. Here, this is a very well noted. Ferric, not ferrous, ferric. Ferric reacts with this one to form Prussian blue. Next one is zinc. Then zinc reacts with this one, then bluish white precipitate. That's why here 1, 2 and 3. Option is 3. Clear? Compared this one more is there. Nickel plus 2 DMG. What is the color? Rose pink color. That also very important. Nickel plus 2 DMG. In laboratory, nickel plus 2 is identified by using DMG. Next, aluminum is identified by using NaOH, gelatinous white precipitate. These are the essential chemical reactions. Clear? Now, we go to the 75. This is a heavy calculated question. Now, Fe3O4 is treated with 4NO to form Fe metal and CO2. Okay. X grams of iron, this is X grams. Okay na? How much iron will be formed in the reaction? How much weight of Fe3O4 is given? 2.32 into 10 power 3 kgs, not grams. And 2.8 into 10 square kgs of CO. Okay, now brought together in a furnace. What is the X value? Here molecular masses are given. What is the molecular mass? Fe3O4 232 gram per mole, CO 28 and Fe is 56. Now I calculate the moles. Previous what I told, first equation is already given equation. Second one is marking. Next one is what is the standard. Third one is what is the given. What is the answer? Any kind of equation related question, this is the concept. One is equation, next marking, next one is standard moles, given moles, answer. Okay. Now, I want, or the weight of this one is given. What is the weight of this one? 2.32 into 10 power 3 kgs. That means this is here 3220 is multiplied by this one into kg changes to grams. Okay na? 2.32 into 10 cube. That means 2320 kgs. That means 2320 into 10 power 3 grams. Similarly, this one also 2.8 into 10 cube kgs is nothing but 280 into 10 power 3 grams. Now, after that I calculate the moles here. What is the equation? First, this is the equation. Okay na? Next one is here 3 components are given. This is the marking. This one, this one, this one. I didn't consider this one. What is the reason? Sorry, this is a CO2. This is a CO2. This is CO2. Clear? Now, I didn't consider this one. We go to this one. How many moles are there? 1 mole. This is a 4 moles. This is a 3 moles. This mass equal 56. This is a 28. This is a 232. Okay. First one, equation completed. Second one, marking completed. Next one is here moles, standard moles. 1, 4, 3. What are the given moles? Given moles. This is weight by molecular mass. Is it 10 power 4 moles? This is 10 power 4 moles. Okay. Now, 2 reactants are there. Then how to identify the limiting reagent? 1 required 4. Here 10 power 4 required how much? 4 into 10 power 4. But here less. So, this is a limiting reagent. What is the limiting reagent? Least number of moles. This is a limiting reagent. So, product decides only limiting reagent. We need not this one now. This one versus this is required. Have you understood? So, carbon monoxide limiting reagent versus product. What is the limiting reagent? Carbon monoxide versus here. Carbon monoxide versus what is the product? Fe. This is the target. This is the target. Okay na? Now, 4 moles gives 3 moles. 4 into 10 power 4 moles, how much weight of Fe? That is nothing but 0.75 into 10 power 4. That means 0.75 into 10 power 3 moles. Then we want a weight. Weight equal to, what is the mole equal to weight by molecular mass? Weight equal to mole into molecular mass. What is the mole? 7.5 into, okay, 10 power 3 into 56 grams. So, 10 power 3 into gram is nothing but kg. Therefore, answer is 420 kgs. Clear? Okay na? What I did? First, weight is kgs, weight changes to grams. I calculate the moles. This is the moles. From this one, this is a limiting reagent. How to identify the limiting reagent? 2 or more reactants are there. Only one reactant is there. There is no limiting reagent. 2 or more reactants are there. Then 2 or more reactant and their concentrations are different. Then least concentrated reactant is called limiting reagent. Okay na? So, here this is a limiting reagent. Clear? This is the answer. If you want first one, I explain the first one. If you want first one, you take a screenshot. This one. Okay na? Thank you.
Brilliant Study Center, India's #1 coaching center for NEET and JEE.